Right now, at the faint outer edge of everything our greatest telescope can see, there is a galaxy that, by every rule we thought we understood, has no business being there. It is too bright, too heavy, and far too old for the moment it sits in, only a few 100 million years after the beginning. And it is not alone. The more carefully we look at the dawn of time, the more the story we told ourselves comes apart in our hands, and the universe underneath it turns out to be bigger and stranger and far less settled than we ever let ourselves believe. So let me ask you the question this whole night is built around. If we finally built an eye powerful enough to measure the true scale of the universe, why does everything it shows us make that universe feel less like a home and more like something we were never meant to fully see? Settle in and let yourself get heavy and still. Subscribe if you haven't already, and stick around, because by the end I promise to answer that question, and the answer is not the one the fear leads you to expect. Let's begin. Part 1. The eye we built to confirm the story. We spent decades and something on the order of $10 billion building a single machine, and we built it to answer a question that sounds almost childish when you say it out loud. We wanted to look back in time, not metaphorically, not through old books or fossils, but literally by catching light that had been travelling toward us since long before the Earth existed, and reading in that light the story of how everything began. The James Webb Space Telescope was designed to see further into space, and therefore further into the past, than any instrument in human history, all the way back toward the first few 100 million years after the Big Bang. And here is the part that matters tonight. We already thought we knew what it would find. The story we had written was a calm one and a comforting one. In the beginning, the theory said there was fire, and then there was a long, patient darkness. After the first flash of creation cooled, the universe settled into a quiet fog of hydrogen and helium, spread thin across an expanding space. Nothing shone yet. There were no stars, no galaxies, no structure of any kind. Just a slowly cooling mist drifting in the dark, waiting for gravity to do its slow and careful work. Astronomers gave this period a name that tells you exactly how they pictured it. They called it the Cosmic Dark Ages, and when they pointed the most expensive eye ever built toward that era, they expected to see almost nothing at all. Maybe a few faint smudges, a few small clouds of gas just beginning to collapse, the first dim embers of the first stars barely lit. That is not what came back. Almost as soon as the deep images began to arrive, the astronomers looking at them realized that something was wrong. Deep in the past, in the slice of time where there should have been nothing but emptiness and patience, the telescope found galaxies. And I do not mean faint little wisps struggling to be born. I mean structures that were already bright, already enormous, already heavy, some of them carrying the weight of hundreds of millions of suns, sitting in a moment when the universe was only a tiny fraction of its present age. The machine we built to confirm our story had, in its very first look, put a crack straight through the first chapter of it. I want you to sit with how strange that is, because it is the seed of everything we're going to walk through tonight. Imagine you spend your whole life certain of how a thing began. You have the timeline memorized. You know what came first and what came second and how long each step took. And then you build a perfect window onto the beginning, and you look through it, and the beginning refuses to match your memory of it. That is the position modern astronomy found itself in. Not a small correction at the edges. A structure at the very start of time that, according to everything we understood about how the universe assembles itself, simply should not have been there yet. The clearest single example of this has a terrible name, so let me strip it down for you. Astronomers catalogued a galaxy they called JWST 14. Forget most of that. The only part you need to hold on to is the number at the end, the one near 14, because that number is a kind of clock. It tells us how much the light from this object has been stretched by the expansion of the universe on its long journey to us, and from that stretch we can work out when the light left. And the answer is that we are seeing this galaxy as it existed roughly 290 million years after the Big Bang. To put that in human terms, if the entire history of the universe were compressed into a single year, we are looking at something from the first few days of January, when by every reasonable expectation the lights had not yet come on. At that moment, the universe was a newborn. By the standard account, it should have been a quiet, half-lit nursery, hot gas and slow gravity and not much else. But JWST 14 is not quiet, and it is not half-lit. It is luminous, it is large across, and it is heavy, holding on the order of hundreds of millions of times the mass of our Sun in a single settled structure. Now think about what building something like that actually requires. Gravity is not a fast worker. It gathers gas patiently, over enormous spans, pulling matter together grain by grain until, after a very long time, a galaxy takes shape. The arithmetic of how long that should take does not fit inside 290 million years. There is not, by our understanding, enough time in that early window for a structure that large to have formed. And yet, recorded in the data, plainly and stubbornly, there it is. This is where the fear that scientists feel about these images actually comes from, and it is worth being precise about it, because it is not a childish fear. It is the fear of a broken timeline. You cannot pour the foundation of a skyscraper, weld its steel, raise its floors, and glaze its windows in an afternoon. The process has a minimum duration, set by how fast the work can physically be done. And what these early galaxies seem to be telling us is that the universe built a finished tower in what should have been the time it takes to dig the first hole. So we are forced to choose between two uncomfortable possibilities. Either our instruments are somehow lying to us, which, given how carefully they have been checked, looks less likely by the month. Or the history of the universe is genuinely different from the story we told, which means our understanding of how reality is put together has a hole in it we did not know was there. I should be honest with you here, because honesty is the whole point of a night like this. Astronomers are not standing around helpless. There are serious, sober ideas about how these galaxies might fit after all. Perhaps we have overestimated their masses, and they are lighter than they first appeared. Perhaps stars formed far more efficiently in the early universe than they do now, packing more light into less time. Perhaps some of that brightness comes not from stars at all, but from monstrous black holes feeding at the centres. These are real proposals, and any of them might soften the problem. So I am not going to tell you the Big Bang is dead, because it is not. I am going to tell you something more interesting and more true. The most successful theory we have ever written about the beginning of everything is under real strain at its very first page, in public, in the data, and no one yet knows which of the possible repairs is the right one. It helps to understand why this telescope, of all telescopes, was the one that broke the story open, because it was built for exactly this and nothing else. The light from the earliest galaxies does not arrive as visible light at all. It leaves those young stars as ordinary starlight, but on its journey of more than 13 billion years, the expansion of the universe stretches it, wave by wave, out of the visible range and deep into the infrared, the range we feel as heat rather than see as colour. Ordinary telescopes are effectively blind to it. So this instrument was built to see in the infrared, with a great golden mirror far larger than anything flown before, and it was flown 1 million miles from Earth and chilled to within a whisper of absolute zero, so that its own faint warmth would not drown out the ancient heat it was straining to catch. Everything about it, the size, the cold, the distance, the colour of light it was tuned to, was chosen to do one thing, to catch the oldest, faintest, most stretched light in existence. And when it finally opened its eye and caught that light, the light disagreed with us. This is worth pausing on because it changes how you should feel about the strangeness. When a cheap instrument returns a strange result, the first suspect is the instrument. But this is the most carefully built, most exhaustively tested scientific eye in human history, and the galaxies it found have been checked and rechecked, their distances confirmed by multiple independent methods, their light broken apart and measured line by line. The strangeness has survived every attempt to make it go away. That is what makes it so unsettling to the people who study it. It is not a smudge that will vanish on a second look. It is a real feature of the real early universe, sitting in the data, waiting for an explanation we do not yet have, and this is only the doorway. Because the galaxies that should not exist are not the end of the strangeness. They are the first loose thread. When you pull on them, the telescope has more to show you, and each new thing widens the picture a little further, until the question stops being about one impossible galaxy and becomes about the shape and the scale and the stability of the entire universe you happen to be living inside. We measured the universe expecting to confirm how small our ignorance was. Instead, we are about to discover how large it really is. So settle in and let your shoulders drop, because the first thing we have to do is walk back into that impossible early galaxy and look at what is inside it. And what is inside it is stranger than the fact that it exists at all. Part 2. The Antique in the New House. The size of these early galaxies is only half of the problem, and it is the smaller half. The larger problem, the one that reaches down and touches what you yourself are made of, is not how big they are. It is what they contain. To understand why that matters, I need you to think for a moment about where the material of your own body actually came from, because the answer connects you directly to this puzzle at the dawn of time. Look at your hand. The carbon in it, the oxygen you are breathing right now, the calcium in your bones, the iron in your blood, none of it was made in the Big Bang. This is one of the most beautiful facts we know, and it is worth saying slowly. When the universe began, it made almost nothing. It made hydrogen, the simplest element, a single particle at its heart. It made helium, the next simplest. And it made a whisper of a couple of light elements beyond that, and then it stopped. That was the entire starting inventory of reality. Everything heavier, every atom that makes a planet solid or a body possible, had to be manufactured somewhere else later, in a furnace hot enough to fuse simple things into complicated ones. And the only furnaces that exist are stars. Here is how the cooking works, and why it takes so long. A star forms out of gathered gas and switches on, and for millions or billions of years it crushes hydrogen into helium in its core, and then heavier things still as it ages. When it finally dies, especially if it dies violently, it scatters all of those newly forged elements out into the space around it, seeding the next generation. Then, new stars form from that enriched gas, and they cook the material further, and they die, and they scatter it again. It is a slow, generational relay. Each cycle takes a very long time, and you cannot cheat it, because you cannot make the heavy elements without first building and burning and killing a star. The carbon in your hand is, quite literally, the ash of dead stars that lived before the sun was born, and the timing of that relay is the whole problem, so let me make it concrete. The most massive stars, the ones that live fast and die in the violent explosions that scatter heavy elements most generously, still take millions of years to form, to burn through their fuel, and to reach the moment of their death. Then the enriched gas they throw out has to cool and gather and collapse again into a new generation, which itself has to live and die before the enrichment builds up to the levels we detect. Each turn of the wheel is slow, and you need several turns to season a galaxy with as much carbon and oxygen as we're seeing. Line those turns up end to end, and they eat through a great deal of time. That is why finding a galaxy already this well-seasoned, so close to the beginning, is so hard to swallow. It is not that a little enrichment happened early. It is that a lot of it seems to have happened before the relay should have finished even its first lap. There is something almost vertiginous in realizing what this means for you personally. You are made of the output of that relay. The oxygen in every breath, the calcium in your teeth, the iron carried in your blood, all of it was cooked in stars and scattered by their deaths, and you have always been able to tell yourself a comfortable story about how long that took, how many generations of stars had to live and die to make you possible. But if the relay was already running, already producing these heavy ingredients, at the very dawn of time, then the machinery that eventually built your body started earlier, or ran faster, or worked in some way we do not yet understand than anyone believed. You are older, in your ingredients, than your own origin story allows. The antique in the new house is not just out there in a distant galaxy. In the most literal sense, it is also in your hand. Now hold that in your mind, and come back to the impossible early galaxy. When astronomers took the light from these earliest objects and spread it out to read its chemical fingerprints, they were expecting to find almost nothing but the simple, primordial gas, because there had not been time yet for the relay to run. Instead, in the light of some of these very early galaxies, they found the signatures of carbon and oxygen already present. In at least one case, in one of the earliest galaxies we have ever measured, oxygen turned up in a quantity that the model simply did not predict for such an early time, and that finding is the real smoking gun, stranger even than the size, because it means that whole generations of stars had already been born, had already lived out their lives, had already died and scattered their ashes, all in a window where there should barely have been time for the first generation to ignite. Let me give you an image for how wrong this feels, because the numbers alone do not carry it. Imagine you walk into a house, and you know, for a certain fact, that this house was built yesterday. The paint is still faintly wet, the concrete has barely set, and you walk into the living room, and sitting there in the corner is a 100-year-old antique chair, worn smooth by a century of use. You would stop in the doorway, because that chair is impossible. That chair proves that someone was here, living, using, aging things, long before this house was supposedly built. The chair is older than the room it sits in, and that is exactly what the carbon and the oxygen are in these early galaxies. They are the antique chair in the brand new house. They are proof of a history that the timeline does not seem to allow. And the question that hangs in the air is the same question you would ask standing in that doorway. Who put it there? And more unsettling still, if the antique is real, then maybe the house is far older than anyone told you. This is the point where the puzzle stops being an abstract debate about distant galaxies and starts to press on something closer to home. For 50 years, essentially every astronomer on Earth agreed on the shape of the past. They told us the story of the cosmic dark ages, that long quiet interval of a few 100 million years during which the universe sat black and patient, waiting for gravity to slowly assemble the first sources of light. It was a tidy story. It was a reassuring story because it described the universe as gradual, predictable, evolving one careful step at a time. And by finding these massive, bright, chemically mature galaxies so absurdly early, the telescope suggests the dark ages, at least as we imagined them, may never have happened the way we thought. The lights did not flicker on slowly over hundreds of millions of years. They seem to have been blazing almost from the start. The universe did not wake up like a person rising slowly from sleep. It looks more like it woke up all at once with a jolt. I want to be careful, because this is exactly the kind of place where it is easy to overclaim, and I would rather you trust me than be impressed by me. This does not overturn our whole picture of cosmic history. Astronomers are actively arguing about it, and some of the possible explanations I mentioned, the overestimated masses, the more efficient early stars, the bright feeding black holes, could ease the tension without any of this being as revolutionary as it feels tonight. But it is a real tension, not an invented one, and it strains a specific and important part of the Standard Model. In that model, the invisible scaffolding of dark matter is supposed to gather first, building the skeleton, and only later does ordinary matter, the stuff of stars, flow in and light up. Seeing ordinary matter already collected into bright, heavy structure so early makes that careful sequence harder to hold. Something about the order of assembly, or the speed of it, is not what we assumed. And if we got an entire chapter of the story wrong, if the dark was actually full of light and structure that we did not expect, then a quiet, uncomfortable question starts to grow. What else in that confident timeline is wrong? What else is hiding in the parts of the past we have not yet looked at closely enough? Because the carbon in your hand was forged in dead stars, and finding that same forging already finished at the very dawn of time means the machinery that made you possible was running earlier, or faster, or in some way we do not yet grasp than anyone believed. The antique chair is real, and once you have seen it, you cannot stop wondering how old the house actually is, which is exactly the question that the boldest thinkers in this field are now, quite seriously trying to answer. Some of them are willing to do something drastic to the clock, and that is where we go next. Part 3. Reading the clock again. If the early galaxies are too big and too rich to fit inside the time we have allotted them, there is an obvious and radical way to fix the problem. You do not argue with the galaxies, you argue with the clock. If there is not enough time in the universe for these structures to have formed, then perhaps the honest response is to ask whether the universe is actually as young as we think it is. And there are serious people, right now, proposing exactly that. The boldest version of this comes from a physicist named Rajendra Gupta, who has suggested something that sounds, on first hearing, close to heresy. What if the universe is not 13.8 billion years old, the age we have all been taught? What if it is nearly twice that, on the order of 26 billion years old? The idea is that we have been reading the cosmic clock wrong the entire time. His model reaches back and revives an old, mostly abandoned notion sometimes called tired light. The idea that photons might lose a tiny amount of energy over the truly enormous distances they travel, and combines it with the possibility that the fundamental constants governing physics have themselves drifted slowly over cosmic history. Put those together, and the light from distant objects would look more stretched, and therefore older and further away than it really is. And if you unwind that effect, the universe comes out roughly twice as old as the standard number. Do you see how neatly that would solve our problem? If the universe has had twice as long to work, then gravity has had all the time it needs to build the early monsters. The impossible galaxies stop being impossible. The antique chair fits the house, because the house was quietly twice as old as the label claimed. It is an elegant escape from the timeline crisis, and that elegance is part of why it gets attention. But I promised you honesty, and here is where I have to hold the line firmly, because this is exactly the kind of idea that can be dressed up to sound more settled than it is. Gupta's model is a minority proposal. It is not accepted cosmology, and most researchers in the field do not believe it. The tired light idea has been challenged again and again for a very long time, precisely because it struggles to explain other things we have measured with great care, the crisp details of the oldest light, the way distant exploding stars dim exactly as an expanding universe predicts. And doubling the age of the universe is not a small tweak. It would force us to tear up our understanding of dark energy and rewrite how we measure expansion itself. It fixes one deep problem by creating a fistful of new ones. So I am not telling you the universe is 26 billion years old. I am telling you that the crisis at the dawn of time is real enough and sharp enough that a serious scientist was willing to double the age of everything to try to resolve it. And that idea earned a hearing rather than a dismissal. That alone should tell you how strange the data has become, and notice what this does to your own footing. You probably carry around, somewhere in the back of your mind, the number for the age of the universe as if it were a fact stamped on a certificate. 13.8 billion years. But it is not stamped anywhere. It is inferred through a long chain of assumptions and measurements from light. Change one link in that chain, one assumption about how light behaves over unimaginable distances, and the entire calendar of existence can stretch or shrink. Your deepest sense of how much time has passed since the beginning is not a fact you can touch. It is a reading, and readings can be wrong. I do not want to leave you thinking that scientists are simply guessing, because they are not, and the reason the standard age holds up as well as it does is worth knowing. That figure of 13.8 billion years is not pulled from a single measurement. It is where many independent lines of evidence happen to meet. The ages of the oldest stars we can find point roughly there. The patterns in the oldest light point there. The way the universe has expanded traced back points there. When many different roads, using different physics, all arrive at nearly the same crossroads, that agreement is powerful, and it is why most cosmologists are not ready to throw the number away over one puzzle at the dawn of time. So when someone like Gupta proposes doubling it, they are not just tweaking one figure. They are proposing to move a crossroads that many separate roads currently agree on, and to explain away all of that agreement as a shared illusion. That is a very heavy thing to ask, which is exactly why the idea sits where it does, on the far and speculative shelf, taken seriously as an attempt but believed by very few. The lesson I actually want you to carry from this is gentler than either the standard number or the radical one. It is that the age of the universe, this thing we recite so casually, is one of the most hard-won inferences human beings have ever made, and that even the most confident version of it is still an inference, built from light and reason rather than rid off a label. There is something quietly moving in that. We are creatures who live for a few decades on a small world, and we have looked out at the sky and reasoned our way, carefully, humbly, sometimes wrongly, back to something like the beginning of everything. Whether the answer is 13 billion years or twice that, the fact that we can even ask the question and argue about it with real evidence is one of the strangest and most beautiful things about being the kind of thing that we are. If Gupta's answer is to stretch the clock, there is another thinker who looks at the same puzzle and does something even stranger. He does not stretch time, he loops it. His name is Roger Penrose, and he is not a fringe figure. He is a Nobel laureate, one of the great mathematical minds of the last century, a man who worked alongside Stephen Hawking on the deepest properties of black holes. And when Penrose looks at these strange early structures, he does not see a new universe that formed too fast. He sees, in his own framework, something closer to a graveyard. He thinks the Big Bang may not have been the beginning of the story at all. He thinks it was a reset. Let me try to give you his picture, because it is one of the most extraordinary ideas in modern cosmology. Imagine the entire life of a universe, from its first fire to its last dying moment. It expands, it forms stars and galaxies, it lives out an almost unimaginable span of time. And then, in the far, far future, everything burns out. Every star dies. Even the black holes, the last dark engines, slowly evaporate away over spans of time so long they make the current age of the universe look like an eye blink, and eventually you are left with nothing but faint light drifting in an endless emptiness, and no matter left with which to measure size or distance or the passage of a moment. Penrose argues that in that final, featureless state, the geometry of the universe effectively forgets its own scale, and that this forgetting can snap the enormous cold ending seamlessly onto a new hot beginning. The end of one universe becomes the Big Bang of the next, a cycle running forever, one universe after another. Now here is why that matters for the galaxies that should not exist. If Penrose is right, then those impossibly mature early structures are not glitches at all. They are inheritances. They are debris that carried across the boundary from the universe that came before ours, remnants that survived the reset and seeded the new beginning with a head start. That would explain why they are so heavy and so chemically rich so early. They did not have to build themselves from scratch in our young universe, because they were never starting from scratch. They inherited the wreckage of a cosmos that died before ours was born. And Penrose claims there is evidence for this hiding in the oldest light we can see. Faint circular patterns he interprets as the scars left by black holes that evaporated in the previous cycle, ripples still spreading through the fabric of our universe like the rings that keep moving across a pond long after the stone has sunk out of sight. I have to tell you plainly that this idea is contested, and that most cosmologists do not accept it. The patterns Penrose points to are disputed, and the statistical case that they require a previous universe is far from settled. So keep it on the right shelf, but keep it, because there is something in it worth carrying with you. Penrose's picture, if it held, would mean that the atoms in your body are in the deepest possible sense second-hand, that we are writing our lives on a page that has been written on before, and erased, and written on again, and that if you look closely at the earliest light, the old ink is still faintly bleeding through. Whether we stretch the clock or loop it, the message from the dawn of time is the same, and it is humbling. The universe is older or stranger than the story we were told, and we have not even begun to talk about how big it is. Part 4. The Wall Around Everything. We have been talking about time, about how old the universe is and how fast it built its first structures. Now I want to turn you around and point you at space, at the sheer size of the thing, because this is where the true scale of the universe reveals itself, and where it stops feeling like a lecture and starts feeling like a room with walls. When you look up at the night sky, you have a certain gut feeling, and almost everyone shares it. You feel that the universe goes on forever. You feel that if you had a fast enough ship and enough patience, you could simply pick a direction and fly in a straight line and keep finding new stars, new galaxies, new worlds, without ever reaching an end. It is a comforting feeling. It is also, in a very specific and important way, not true. The universe has an edge. Not an edge in the sense of a wall you could crash into, and not the edge of space itself, but an edge to what you can ever see or touch or know. It exists because light, for all its speed, is not infinitely fast. Light takes time to travel, and the universe has only existed for a finite span. So there is a maximum distance from which any light could possibly have reached us in the entire history of everything. Beyond that distance, light simply has not had time to arrive yet, no matter how long it has been travelling. That boundary wraps around us in every direction, forming a sphere, and astronomers call it the particle horizon. Everything inside it is the observable universe. Everything outside it is for now completely cut off from us. We cannot see it. We cannot touch it. We cannot receive any signal from it. It might as well be in another world. Already that should shift something in you. The universe you can actually study, the one in all the beautiful images, is not everything. It is a bubble, a finite region centered from your point of view on you. And beyond the skin of that bubble, there is almost certainly far more universe, perhaps infinitely more, that you are permanently sealed away from. But that is not even the unsettling part. The unsettling part is what the bubble is doing. Because the bubble is not a fixed, comfortable enclosure. In the way that matters most, it is closing. Here is the mechanism, and I will go slowly, because it is subtle, and it is worth understanding rather than just being told. Space itself is expanding. Every distant galaxy is drifting away from us as the space between us and it stretches. And the further away a galaxy is, the faster it recedes, because there is more stretching space in between. For the most distant galaxies, the ones near the edge of our bubble, this recession is so fast that it exceeds the speed of light. Now, nothing is moving through space faster than light, which is forbidden. but space itself can carry things apart faster than light, because the expansion is not motion through space, it is the growth of space, and that has no speed limit. And what it means is stark. The most distant galaxies are being carried away from us so quickly that their light, the light they are emitting right now, will never reach us. It is being outrun by the expansion. Those galaxies are, in a real and permanent sense, falling off the edge of our world. Let me make sure you feel the weight of that, because it is easy to hear it as an abstraction. Every second, as the universe expands, a little more of it crosses beyond our horizon and is lost to us forever. Galaxies that we can see today, whose ancient light is still arriving, are slipping toward that boundary. Given enough time, they will cross it, and their light will stop coming, and they will vanish from our reality, not because they were destroyed, but because the space between us grew too fast for any message to survive the crossing. We are not standing on an open plain that stretches without limit in every direction. We are inside a bounded bubble whose walls are quietly, steadily sealing off the rest of everything. The true scale of the universe is not just enormous, it is enormous and shrinking from view, and every distant light you can still see is one you are slowly losing. I want to take you somewhere for a moment, because there is a scene at the end of this that I think about often, and I want you to see it with me. Come with me to the far future, unimaginably far, long after our sun has died and the earth is gone. Picture a single observer, some curious mind on some distant world, standing under the sky of their planet on a clear night, looking up, the way you might be looking up tonight. But the sky above them is almost empty. The expansion has run for so long that nearly every other galaxy has already crossed beyond their horizon and disappeared. And this observer is watching the very last one, the final distant galaxy, a faint smudge of light near the edge of everything they can see, drifting slowly toward the boundary. They watch it dim. They watch it stretch and redden as its light is pulled thin by the expanding space, and then, quietly, without any drama, it slips across the horizon and is gone, and now their sky holds only their own local stars, and beyond them, nothing. And here is the part that stays with me. That observer would have no way, even in principle, to know that the greater universe had ever existed. No telescope, however perfect, could show them the galaxies that had already left. As far as any experiment they could ever perform is concerned, their small island of stars is the entire cosmos, floating alone in an endless dark. The evidence of everything else will have been carried permanently out of reach. There is a number worth sitting with here, because it makes the bubble feel real. The edge of the observable universe, the particle horizon, lies something like 46 billion light-years away in every direction, even though the universe is only about 13.8 billion years old. That sounds like a contradiction, and the resolution is the whole strange point. The light we are receiving from the most distant objects set out when they were far closer, but while that light was in transit, the space between us and its source kept stretching, carrying those objects much further away than they were when they emitted it. So the bubble we can see is far larger than the distance light could have simply crossed, and yet it is still finite, still bounded, still a bubble, and beyond its edge there is almost certainly far more, perhaps endlessly more, that we will never receive a single photon from, not because it is not there, but because the space in between is growing faster than any signal can cross it. We are living right now in a privileged and temporary moment when the universe is still full of light, when we can still see the galaxies and read their history, and know that we are part of something larger. That window is open now. It will not stay open forever. And there is something almost tender in that. A reason to look up while looking up still shows you anything at all. But I raised this scene for another reason too, because it plants a question that we're going to need very soon. If our bubble has a wall, and if things can fall off the far side of it and be lost to us, then a natural and slightly frightening question follows. What is on the other side of the wall? If we are sealed inside a room, however enormous, then something is outside that room. And the strange thing, the thing that turns this from philosophy into physics, is that there may be a hint buried in the motion of the galaxies themselves that something outside our bubble is reaching in. Standard science usually tells us we can never know what lies beyond the horizon, but there is an anomaly in the data that refuses to be quiet about it, and that is where we go next. Part 5. Something is pulling. If the observable universe is a bubble, and if we are sealed inside it, then everything within that bubble should, in a broad sense, behave according to what the bubble contains. The galaxies should drift and cluster and move under the pull of the matter we can see and measure. Add up all the mass inside our horizon, and you should be able to account for how things move. That is the expectation. And there is a disputed, unsettling observation that seems to some astronomers to break it. The observation has a name that sounds like something out of a ghost story, and honestly, the name fits. It is called dark flow. Here is what was reported. A team of scientists set out to study the motion of hundreds of enormous galaxy clusters, some of the largest gravitationally bound structures in existence, each one containing thousands of galaxies. In a normal, well-behaved universe, these clusters should be drifting more or less randomly, each pulled this way and that by its local neighborhood of matter, with no particular agreement between them. But that is not what the team reported seeing. They reported that the clusters were not moving randomly at all. They seemed to be streaming together, all of them, in the same direction, toward one particular patch of the sky, and moving fast at speeds of hundreds of kilometers every second. Not a random scatter, a coordinated current, a river of galaxy clusters all flowing the same way. And that is a genuine problem, if it is real, because there does not seem to be enough mass inside our observable bubble to explain a pull that strong and that organized. Something would have to be tugging on all of these clusters at once, from a single direction, with enormous force. And if the source of that pull is not inside our bubble, then the only place left for it to be is outside, beyond the horizon, past the wall. The dark flow, if it is what it appears to be, would be the fingerprints of something enormous lying outside our observable universe, reaching across the boundary and pulling everything inside toward it. Let me give you an image, because the physics here is easier to feel than to state. Imagine you are locked in a room with no windows. The walls are solid, you cannot see out, and suddenly you notice that all the furniture in the room, the heavy steel tables and cabinets, have begun to slide slowly across the floor, all of them in the same direction, toward the north wall. You cannot see through that wall, but you do not need to. You know, with certainty, that there must be something on the other side of it, something with an enormous pull, a giant magnet, a great mass, dragging everything toward it. You infer the unseen thing from the motion of the things you can see. That is what dark flow would be. The furniture of our universe, the galaxy clusters, sliding toward a wall we cannot see through, revealing by their motion the shadow of a titan on the other side. What makes this kind of reasoning legitimate rather than fantasy is that we have used it before and been right. Almost everything we know about the unseen contents of the universe, the dark matter that outweighs all the stars, the dark energy that is stretching space apart, we know only through its effects on the things we can see. We have never held a piece of dark matter. We infer it entirely from how galaxies spin and how light bends, from motion that visible matter alone cannot explain. So the logic behind dark flow is not exotic. It is the same detective work that built modern cosmology. The difference, and it is a crucial one, is that dark matter and dark energy show themselves consistently, everywhere we look, in measurement after measurement, while dark flow has not. It appeared in one kind of analysis, and then failed to appear in others, and that inconsistency is exactly why the careful response is doubt. I dwell on this because it captures something about the whole night. Again and again we are meeting things at the very edge of what we can measure, where a real signal and a trick of the data look nearly identical, and where the honest scientist has to hold two feelings at once, the excitement of a possible discovery and the discipline to say we do not yet know. Dark flow lives in that uncomfortable place. It might be the first hint of something enormous beyond our horizon, or it might be a pattern our methods conjured out of noise. And sitting with that uncertainty, without rushing to either the thrilling answer or the dismissive one, is itself a kind of maturity that the true scale of the universe demands of us. Now I have to stop and be very careful with you, because this is one of those places where the story is so seductive that it is easy to forget it might not be true. Dark flow is contested, it is not established fact. Later and more careful surveys, including detailed studies of the oldest light in the universe by the Planck mission, did not confirm it, and many cosmologists regard it as unproven, quite possibly a statistical illusion, a pattern the human eye and the human method are prone to seeing in noisy data even when nothing is there. So I am not going to tell you that there is definitely a titan outside our universe pulling us toward it. What I am going to tell you is that the possibility was taken seriously enough to measure and to argue about, and that it remains an open question rather than a closed one. And that, in itself, is the point I keep circling back to tonight. The true scale of the universe includes the size of what we do not know, and here is a case where what we do not know might literally be larger than the entire visible cosmos. Because think about what is really being asked here. We started the night worried that a few galaxies formed too early. Now we're standing at the edge of our observable universe, looking at the possibility that everything we can see, every galaxy, every cluster, the whole enormous bubble, might be drifting under the influence of something we can never directly observe. If dark flow is real, then the universe you can study is not just incomplete. It is being moved by a hand it can never see. And whether or not this particular anomaly survives, it opens the door to a question that other, firmer evidence is also whispering. Are we alone in the deepest possible sense? Is our universe the only one? Or is it one bubble among many, floating in some larger space, occasionally close enough to another to feel its presence? That question sounds like pure fantasy. But there is a mark on the sky, a genuine one, a cold and specific wound in the oldest light we can see that some serious physicists believe might be exactly that. The bruise left where our universe touched another, and that mark is where we go next. Part 6. The Bruise in the Sky. To understand the strange cold mark I want to show you, you first have to understand the map it appears on, and this is one of the loveliest things human beings have ever made. So let me set it up properly. When we look out into space, we are looking back in time because light takes so long to travel. Look far enough, and you eventually reach the oldest light there is, light from a time when the universe was only a few 100,000 years old, when it first became transparent and released the glow it had been holding. That light has been travelling ever since, stretched now into a faint hiss of microwave radiation that fills the entire sky in every direction. We call it the cosmic microwave background, and it is, in a real sense, a baby photograph of the universe. It is the earliest picture we will ever be able to take. Think about what a strange inheritance that photograph is. There is a wall we can never see past, not the edge of space this time, but the edge of clarity, because before that ancient moment the universe was so hot and dense that it was opaque, a glowing fog that light could not travel through freely. Only when it cooled enough for the fog to clear did light finally break loose and stream across the universe, and that first freed light is what we are still catching now. So the baby photograph is not just old. It is the oldest thing there is to see, the surface of the last fog, the moment the universe first became transparent. Everything before it is hidden behind that glowing curtain, and everything after it, all the stars and galaxies and worlds, formed in the light that photograph captured leaving. When you look at a map of the cosmic microwave background, you are looking at the universe's first visible instant, the closest to the beginning that light itself will ever let us come. And the thing that makes that map so precious to cosmologists is precisely how smooth it is, and how the tiny imperfections in it are not flaws but seeds. Those faint temperature ripples, differences of less than a fraction of a degree from place to place, mark where matter was very slightly more crowded and very slightly more sparse. And gravity took those whispers of difference and, over hundreds of millions of years, amplified them, pulling the crowded places into the first stars and galaxies, leaving the sparse places to become the voids. Everything we see in the sky today, every structure, grew from those gentle patterns in the oldest light, which is why an anomaly in that map, a patch that does not fit, matters so much. It is not just a cold spot on an old photograph. It is a flaw in the seed pattern from which the entire visible universe grew, and a flaw there could mean something happened at the very beginning that our story does not include. And when we map that ancient light, measuring its temperature across the whole sky, we find something that is itself a kind of miracle. It is almost perfectly uniform. Wherever you look, the temperature is nearly identical, the same to a fraction of a degree. The infant universe was extraordinarily smooth, extraordinarily even, a nearly featureless glow. This uniformity is one of the deep facts our theories have to explain, and it is beautiful, but almost is not perfect. And when astronomers looked very carefully at that map, they found, in one particular region of the sky, an area that does not fit, a patch that is unusually, anomalously cold, and it is not small. It spans a region something like 1 billion light-years across. In the smooth baby photograph of the cosmos, there is one large, dark bruise. For years, the debate over this cold spot was cautious and technical. Some argued it was simply a statistical fluke, the kind of rare but not impossible cold patch you might expect to find somewhere if you searched a large enough sky, no more meaningful than finding one unusually tall person in a crowd. Others went looking for a physical cause and found a promising one. It turns out there may be an enormous underdense region along that line of sight, a supervoid, a place where galaxies are unusually sparse, a great emptiness. Light passing through such a void can lose a little energy on the way, arriving slightly cooler, and that could account for much of the chill. This is a largely mainstream explanation, and it may well be the answer. I want you to hold on to it as the sober, likely truth before I show you the stranger possibility, because the stranger possibility is intoxicating, and I do not want it to sweep you away. Here is the stranger possibility. There is a physicist named Laura Massini-Houghton who has argued for a genuinely radical reading of that cold spot. Her framework begins with an idea that is speculative but taken seriously in parts of theoretical physics, that our universe might be just one bubble in an immense foam of universes, countless bubbles of reality, each with its own beginning, drifting and jostling in some larger space. And if that is true, then something becomes possible that would otherwise be unthinkable. Bubbles that drift can touch, universes can collide, and she has argued that early in the history of our universe, our bubble may have brushed against a neighbour, another entire universe, and that such a collision would have left a mark. It would have pushed matter aside and scarred the fabric of our young cosmos, leaving behind a cold, damaged region. And the cold spot in her reading could be that scar, the point of impact, the bruise left where our universe touched another one. Let me give you the image she reaches for because it makes the idea almost tactile. Think of two soap bubbles floating in a sink drifting toward each other. When they meet, they do not simply pass through. They press against each other, and each one flattens slightly at the point of contact, developing a shared, altered wall where they touched. If Massini-Houghton is right, the cold spot is that flattened place. It is the mark on our bubble where another reality pressed in from the outside, and you can feel, I think, how enormous a claim that is, because it would mean that the word universe, which we use to mean everything, is a lie. Our universe would not be everything. It would be one thing among many, and we would already, perhaps, have been touched by a neighbour and carry the bruise of that contact written into the oldest light in our sky. I have to hold the honest line here as firmly as I have held it all night, maybe more firmly, because this is the most seductive idea we have touched so far. This is a minority view. Most cosmologists prefer the supervoid explanation, or the possibility that the cold spot is, after all, just a rare fluke. There is no consensus that it is a scar from another universe, and you should not walk away tonight believing that we have detected a collision with a neighbouring reality. We have not. But this is a published serious proposal from a real physicist, wrestling with the deepest question it is possible to ask, whether our universe is alone, and it belongs in any honest tour of the true scale of things, clearly labelled as the speculation that it is. Because even as a possibility, even as an idea we cannot yet confirm, it does something to your sense of place. It means that our bubble might not be safe in isolation. It means we might be floating in a crowded space and might have already taken a hit. And if we collided once, then collision is a thing that can happen, and the universe is far more crowded and far less lonely, or far more dangerous than we ever imagined. And speaking of our place, of where we sit and how we move, there is one more comfort I need to take away from you before we go looking for company among the stars. You think you are sitting still. You are not. Part 7. We are not sitting still. There is a comfort most of us carry without ever examining it, and I am about to take it away gently, because you will feel the scale of the universe more honestly once it is gone. The comfort is this. You imagine, somewhere in the back of your mind, that our galaxy, the Milky Way, is sitting more or less still. You picture it drifting slowly and peacefully through the emptiness, like a raft resting on a calm sea, turning gently, going nowhere in particular. It is a restful image. It is also completely wrong. We are not resting. We are being hurled across the universe at a speed that is almost impossible to hold in your head. Here is how we know, and it comes back to that baby photograph of the cosmos, the oldest light. That ancient glow fills the sky evenly, and because it does, it gives us something we otherwise would not have, a kind of universal backdrop against which we can measure our own motion. If we were truly sitting still relative to the universe as a whole, that background light would look the same temperature in every direction. But it does not. In the direction we're moving, it looks very slightly warmer and more compressed, and in the direction we are leaving behind, it looks very slightly cooler and stretched. The same way the pitch of a siren rises as it comes toward you and drops as it moves away. From the size of that shift, we can read our speed. And the number is extraordinary. Our galaxy, along with its whole neighborhood of companion galaxies, is moving at roughly 630 kilometers every second relative to that ancient light. Let me put that in terms you can feel. That is over 1.4 million miles per hour. You are right now sitting still in your room, and your room is on a planet, and that planet and its star and its entire galaxy are being carried through space faster than any object human beings have ever built. So the obvious question is, why? What could possibly be heavy enough or powerful enough to drag an entire galaxy with its hundreds of billions of stars at more than 1 million miles an hour? For a long time, astronomers had a partial answer. They believed we were being pulled toward an immense concentration of mass, a dense region crowded with galaxies, which they named, with unusual honesty, the Great Attractor. It made sense. Gravity pulls, and here was a great mass to do the pulling. But when they did the careful arithmetic, the numbers did not add up. The Great Attractor, for all its size, was not heavy enough to explain how fast we were actually moving. Something was missing. We were being pulled harder than the visible pull could account for, and for years that gap sat there, unexplained. The answer, when it came, was one of the strangest and most beautiful results in recent cosmology, and it arrived in 2017 from a team led by the astronomers Yehuda Hoffman and Brent Tully. They realized we had been thinking about it wrong. We were not only being pulled from the front, we were also being pushed from behind. Directly opposite the direction of our motion, they found not a great mass but a great emptiness, an enormous region of space unusually empty of galaxies, a true void, which they named the dipole repeller, and here is the elegant physics of it. In a universe where matter is spread unevenly, an empty region effectively pushes. It is not that emptiness exerts a force in the way a mass does. It is that everywhere else has more matter pulling than the void does. So the net effect, compared to the emptiness behind us, is that we are shoved away from the void and toward the fuller regions ahead. We are being pulled from the front by the crowded places and pushed from behind by the empty one, sandwiched between a fullness and a void, caught in a current that spans hundreds of millions of light years. Sit with what that actually means for you. You're not standing on solid, stationary ground in a stable universe. Everything you have ever known, every person you love, every place you have ever been, the whole Earth and Sun and galaxy, is being swept across the cosmos at more than 1 million miles an hour toward a destination you did not choose and cannot change, driven by the pull of distant crowds and the push of a distant emptiness, forces that were set in motion long before there were any eyes to notice them. We are not steering. We never were. We are debris caught in a current, carried along by the large-scale shape of a universe that is far more dynamic, far more violent, and far more indifferent to us than the peaceful raft we imagined ourselves to be. And this current is not the only motion we are wrapped inside. Stack them up and it becomes almost comic. You are spinning on the surface of the Earth at hundreds of miles an hour. The Earth is racing around the Sun at tens of thousands of miles an hour. The Sun is orbiting the center of the Milky Way at something like 500,000 miles an hour, dragging you and everything you know on a lap so enormous it takes hundreds of millions of years to complete. A lap the Sun has made only a couple dozen times in its whole existence. And the entire galaxy, with all of that nested motion inside it, is itself being swept through the cosmos at more than 1 million miles an hour by the pull ahead and the push behind. You're not doing one thing when you sit still. You're doing all of these at once, motion inside, motion inside, motion, and you feel none of it, because everything near you is moving together, and there is nothing close enough and still enough to feel yourself moving against. There is a strange comfort available in that, if you look for it. The reason you feel perfectly still while being hurled through space in 6 nested ways is the same reason the people you love feel still to you. We're all being carried together, in the same current, at the same speed, and so from the inside it feels like rest. The violence of it is real, but it is shared, an emotion that everything around you shares is indistinguishable from stillness. Perhaps that is the only kind of stillness there ever was, not the absence of motion but the grace of moving together. I take that comfort away from you not to frighten you, but because it prepares you for what comes next. Because once you understand that we are small and moving and caught in currents we cannot feel, you're ready to ask the question that this scale has been driving toward all night. We are one galaxy among hundreds of billions, being carried across a bubble whose edges are slipping away, possibly nudged by things outside it entirely. In all of that immensity, all those stars, all those worlds, are we alone? And for the first time in history, we have built a tool that can actually begin to answer that question, not by waiting and hoping, but by hunting. So let us turn the telescope outward, away from the beginning of time and the edge of space, and point it at the worlds next door. Let us go looking for company. Part 8. Turning the telescope into a predator. For most of the time that human beings have seriously searched for life beyond Earth, we have done it in a way that, looking back, was almost touchingly polite. We listened. We built enormous radio dishes and pointed them at the stars and waited patiently for a signal, for someone out there to call us. The whole strategy rested on a quiet assumption we never really examined, the assumption that if intelligent life existed, it would want to be found, that it would be broadcasting, reaching out, hoping for contact just as we were. So we sat by the cosmic telephone and we waited for it to ring. And for decade after decade, it did not ring. We heard nothing, just the faint, indifferent hiss of the universe, the crackle of distant stars and cold radiation, and underneath it, silence. So we changed our approach. We stopped being polite, and we stopped waiting. We realized that a civilization that wanted to hide could simply choose not to broadcast. It could turn off its radios. It could go quiet. But we also realized that there is one thing a living world cannot easily hide, no matter how careful it is, and this insight changed the entire search. A world with life on it cannot hide its air. Life is a chemical process. It breathes. It burns fuel and releases waste. Every living thing on Earth, from the bacteria in the soil to the trees in the forest to the animals in the fields, is constantly changing the chemistry of the atmosphere, pumping gases into it, keeping it stirred up and out of balance. You might be able to hide your cities and encrypt your signals, but if you are alive, and if there are enough of you, you change the composition of the air around your entire planet. And the air of a planet is not something you can switch off. So we turned our new telescope into something more like a hunter, and we began to sniff the atmospheres of distant worlds, daring them to hide from us. Now you might reasonably wonder how that is even possible. How can any instrument, however powerful, taste the air of a planet trillions of miles away, a planet we can barely see at all? The method is so clever and so beautiful that I want to walk you through it, and I want you to picture it as it happens. Imagine a bright lamp on a far wall, shining steadily. Now imagine someone walks between you and the lamp, and in their hand they are holding a glass of coloured water. As they pass in front of the light does not simply get blocked. Some of it passes through the glass of water on its way to your eye, and as it passes through, the water steals certain colours from it and lets others through. So the light that reaches you is subtly changed, tinted, carrying the signature of what it passed through. Now scale that up to a star and a planet. The star is the lamp blazing steadily. The planet is the person walking past. And when the planet crosses in front of its star, from our point of view, a thin sliver of the star's light does not hit the solid body of the planet, but instead grazes the very edge of it, passing through the thin ring of the planet's atmosphere on its way to us. And in those few hours, as that starlight threads through the alien air, the gases in that atmosphere steal specific colours from it. Oxygen removes one precise shade. Methane removes another. Carbon dioxide takes a third. Each gas leaves its own fingerprint, a set of missing colours, a barcode written in absence. And when that light finally crosses the enormous gulf of space and falls onto the mirrors of our telescope, we spread it out and we read the barcode. We read which colours are missing, and from that we can tell you what is floating in the sky of a world no human will ever visit. We are not guessing anymore. We are reading the receipts. Let me put you inside that moment, because it is one of the quiet wonders of our age, and I do not want it to pass as a technicality. Somewhere out there, a planet swings in front of its star as it has done silently for billions of years with no one watching. But this time, someone is watching. The starlight pours out in every direction, and one narrow thread of it slips through the upper edge of that planet's atmosphere, brushing past whatever clouds and gases wrap that distant world, picking up their signature and then flies, unbroken for years across the dark, carrying its faint message until it arrives here at a mirror we lifted into space for exactly this purpose, and we catch it. We take that single, delicate thread of filtered starlight and we unfold it, and we find, written in the colours that are missing, the chemistry of an alien sky. We're effectively looking through the window of a distant world to see what its air is made of. And this is not science fiction. This is happening. We have already read water vapour in the atmospheres of distant planets. We have already read carbon dioxide. The hunt is real, and it is underway. And there is a sharper edge to this hunt, because the same method that can find life can, in principle, find civilization. A living world betrays itself through the ordinary gases of biology, but an industrial world might betray itself through gases that biology never makes at all. There are certain compounds, the artificial chemicals we once used in spray cans and refrigerators, that no natural process on any planet is known to produce. They come only from factories, only from chemistry done on purpose. If we were ever to read the air of a distant world and find those artificial signatures floating in it, there would be very little room for doubt. It would not be a hint of microbes in some ancient sea. It would be the exhaust of an industry, the chemical shadow of a technological society. And it would mean, almost beyond argument, that someone down there had built something. We are in effect learning to look through the windows of distant houses to see whether the lights are on and whether anyone has been running the machines. So far, the honest answer is that we have not found that, and the not finding is itself becoming a kind of data. As the survey of nearby atmospheres slowly grows, a pattern is starting to press on the people who study it, and it is not the pattern we hoped for. The stars themselves are part of the trouble. Many of the most common stars in the galaxy are small, cool red dwarfs, and while they burn for an extraordinarily long time, many of them are prone to violent flares, lashing their nearby planets with radiation that could strip an atmosphere down to bare rock. World after world that we might have hoped was gentle turns out to orbit a temperamental star, or to have lost its air, or to sit wrapped in a heavy, finished, unmoving atmosphere. The doors keep opening onto stillness, and that stillness is where the wonder of the hunt starts, quietly, to turn into something colder. And what we are truly hunting for is not any single gas. It is imbalance. It is chemistry that should not be able to sustain itself. Look at the air you're breathing right now. It is full of oxygen, and it also contains methane. And here is the thing. Those two gases are enemies. Put them together and they react. They destroy each other. They should vanish from the air within a geological blink. The only reason both are present in Earth's atmosphere at the same time is that life keeps furiously pumping out both, faster than they can cancel. Our air is out of balance, chemically restless, held in a state it could never reach on its own, and that restlessness is the signature of life. It is the smoke that proves the fire. So when the telescope reads the air of a distant world, it is not just asking what is there. It is asking whether the chemistry is agitated, unbalanced, alive, or whether it is calm, settled, finished. And the early answers are where the wonder starts to turn cold. Because so far, so much of what we find looks calm, balanced. Heavy blankets of carbon dioxide or nitrogen, worlds where all the chemical reactions ran their course long ago and stopped, where nothing stirs the air anymore, stable, finished. And in this context, stable is a terrible word, because stable can mean dead. We keep opening doors, hoping to hear a riot on the other side, and so far we keep finding quiet, still rooms where nothing has moved for an age, which brings us to the hardest question of the night and the loneliest. Part 9. The Silence and the Dark Forest. We have built the most powerful eyes and ears in human history, and we have pointed them at the sky, and we have hunted for the breath of life on distant worlds, and mostly what comes back is silence. Calm atmospheres, empty static. No signals, no clear signatures, no unmistakable sign that anyone else is out there. This silence has a name among the people who think about it most. They call it the Great Silence, and it is one of the most unsettling facts in all of science, because on the face of it, it makes no sense. The universe is enormous and old. There are hundreds of billions of galaxies, each with hundreds of billions of stars, and we now know that planets are everywhere. The universe has had billions of years for life to arise and spread. By any naive counting, the sky should be crowded, noisy, full of company, and instead it is quiet. So the question becomes almost unbearable. Where is everyone? And there are several answers people give, and each one is a different kind of cold. The first answer is the gentlest, and it is called the rare Earth hypothesis. It says, quite simply, that we may be alone because worlds like ours are almost impossibly rare. We tend to assume that life is easy, that if you just add water and warmth to a rock, biology will bubble up more or less automatically. But look at how much had to go right for you to be here. You needed a star that burned steadily for billions of years without violent flares that would strip away a planet's air, and the telescope is showing us that many stars are far more violent than ours. You needed a planet at just the right distance, with a molten core generating a magnetic field to shield it from radiation, and we have watched worlds like Mars lose their core and their field and their air and die. You needed a large moon to steady the planet's tilt so the seasons would not swing into chaos. You needed a giant planet further out to sweep up the worst of the incoming debris. Each of these is a lottery, and life as we know it needed to win all of them at once. The rare Earth idea says that the combination is so unlikely that habitable worlds might be scattered so thinly across the cosmos that we will never meet another, that we are not being ignored. There is simply, almost, no one there. The second answer is sharper, and it has a name that has haunted me since I first understood it. It is called the Great Filter. The idea is this. Somewhere on the long road from lifeless chemistry to a civilization that spreads across the stars, there is a barrier, a filter, that almost nothing gets past. Some step in the process is so hard, so unlikely, that it stops nearly every attempt cold. And the terrifying part is not that the filter exists. It is that we do not know where it lies. There are two possibilities, and they could not be more different. Either the filter is behind us, or it is ahead of us. If the filter is behind us, then the hard part is already done. Maybe the leap from dead matter to living cells is the great impossible step, and we are among the almost unimaginably rare worlds that made it. In that case, the silence is our reassurance. We are the lottery winners, and the road ahead is open. But if the filter is ahead of us, the picture is a nightmare. It would mean that the hard step is not in our past, but in our future. That reaching intelligence and technology is relatively easy, but surviving them is nearly impossible. That civilizations keep arising and keep hitting some wall and keep destroying themselves before they can spread. In that reading, the silence is not empty because no one was ever there. The silence is a graveyard. It is full of the places where everyone died young, and we are sprinting toward the same wall that killed them, unable to see it. What makes the Great Filter so hard to shake is that we can look at our own short history and see, uncomfortably, how a filter ahead of us might work. We have existed as a species for a couple 100,000 years, and for almost all of that time we were harmless, no more able to threaten ourselves than any other animal. And then, in the last handful of decades, a sliver of our whole existence, we learned to split the atom, to rewrite the code of living things, to change the chemistry of our entire planet's air. We went from harmless to capable of ending ourselves in less time than a single old tree has been standing. It is at least possible that this is a general rule, that intelligence tends to arrive at world-altering power very suddenly, before it has learned the patience or the wisdom to survive holding it. If that is the shape of the filter, then the silence is not a mystery at all. It is the sound of a galaxy full of civilizations that each reached this exact moment, this narrow window between gaining power and learning to survive it, and did not make it through. I want to be careful and fair, because the Great Filter is a framework for thinking, not a proven law, and there is real hope woven through it. We genuinely do not know where the barrier lies, and the honest possibility remains that it is behind us, that the hard step was the origin of life itself, or the leap from simple cells to complex ones, and that we are on the lucky side of it with the road ahead more open than we fear. The silence could just as easily be reassurance as warning. But the reason people keep returning to the darker reading is that it fits the quiet so neatly, and that it places the decisive test not in the distant past, but in our own hands now, in the choices of the next few generations. It turns a question about the cosmos into a question about us. I want to stop here, because I think this deserves stillness, and because if you have been drifting towards sleep, this is the thought I want to leave in the quiet with you. Consider for just a moment the possibility that we truly are alone, not alone on our continent or our planet, but alone in a way that is almost too large to feel. that in all the immensity we've been mapping tonight, all those galaxies, all those currents and voids and shrinking horizons, we are the only place where the universe woke up, the only place where matter arranged itself into something that could look back out and ask what it all means. If that is true, then we're not a small and unimportant accident on a minor world. We are something closer to the opposite. We are the single candle in an enormous dark room, and the burden of that is immense, and so is the preciousness of it. Because if we are the only light, then keeping that light lit is not someone else's job, it is ours. And if it goes out, the room goes dark again, and there is no one left to notice that it was ever lit at all. Hold that. It is the loneliest thought in this whole night, and it is also, if you turn it just slightly, the beginning of the most important one. There is a third answer to the silence, and it is the coldest of all, and I include it because honesty requires it, though I want to be clear it is more a dark thought experiment than a proven law. It is called the dark forest, and it comes as much from a work of fiction and from the hard logic of survival as from any observation. It says the silence is not accidental at all. It is deliberate. Imagine that the universe is not an empty room, but a dark forest at night, and that every civilization in it is a hunter, moving quietly, listening. You do not know if the other hunters are kind or cruel. You cannot know across the enormous distances and the long delays whether a stranger means you well or means to destroy you. And in that uncertainty, the safest thing, the only truly safe thing, is to stay silent and hidden, and to assume that anyone who reveals themselves is either a fool or a threat. In the dark forest, the ones who call out get found, and the ones who get found do not last. So everyone stays quiet. The silence in this reading is not the absence of life. It is the sound of a universe full of frightened hunters, all holding their breath, all hiding from each other and from something. And if that is true, then we, with our radios and our messages and our probes carrying maps to our home, have been doing something very dangerous. We have been the one creature in the forest walking around with a lantern singing. Whether that was a mistake is a question we will come back to, but first I have to tell you that even the ground we're standing on, the physics itself, is not as solid as it looks. Part 10. The Rotting Stage. We have spent this night learning that the universe is older or stranger than we thought, larger and more bounded than we imagined, moving and crowded and possibly not alone. But through all of it, we have been standing on one last assumption, and it is the deepest one, so deep that we rarely even notice we are making it. We have assumed that the stage itself is solid, that the laws of physics are fixed, unchanging rules, the steel framework that holds reality together, and that whatever strange things happen in the universe, at least the rules of the game stay the same. I have to tell you now that the telescope and the physics that comes with it is beginning to suggest that even the framework may be bending, and this is where the word scary in tonight's question earns its place honestly. The first crack is real, it is measured, and it has a name. It is called the Hubble tension, and it is one of the most serious unsolved problems in all of cosmology right now. It comes down to a disagreement, and to understand it, you need to know that there are two completely different ways to measure how fast the universe is expanding. The first way looks at the beginning, at that oldest light, the baby photograph of the cosmos, and uses the detailed patterns in it to calculate how fast the universe should be expanding today. The second way ignores the beginning and simply measures the nearby universe directly, watching how fast the galaxies around us are actually receding, using a careful ladder of distance markers, special stars and exploding stars whose true brightness we know. Two methods, one looking forward from the dawn of time, one measuring the here and now, and by every reasonable expectation, they should give the same answer. If you measure your height with a ruler today, and you also calculate your height from how much you grew each year since birth, you had better get the same number, or something is badly wrong. They do not give the same number. The early universe method says the universe is expanding at a rate of around 67 kilometers per second per unit of cosmic distance. The nearby method says it is expanding faster, at around 73, and these are not sloppy measurements with wide error bars that happen to overlap. Both have been refined for years, made more and more precise, and as the precision improved, the gap did not close. It hardened. The disagreement is now large enough and solid enough that it cannot be waved away as measurement error. It is a genuine crack running down the middle of our standard model of the universe. And James Webb, by sharpening our measurements of those nearby distance markers, has not healed the crack. It has made it harder to blame on a mistake. Something in our understanding is wrong. Either we are missing an unknown ingredient in the early universe, or the properties of empty space are changing as the universe ages, or there is some deep error we have not found. It is like looking in a mirror and seeing your reflection move a fraction of a second after you do. It is a small thing, and it means the system is glitching. You might reasonably ask why a disagreement in the 6th or 7th digit of one number should matter so much, and the answer is that this particular number is load-bearing. The expansion rate is woven into almost everything: the age of the universe, its size, its composition, its fate. If the two ways of measuring it truly cannot be reconciled, then something in the chain of assumptions connecting the beginning of the universe to the present day is wrong, and we do not know which link it is. Some physicists suspect a missing ingredient in the early universe, a form of energy that flared briefly and then faded, nudging the early expansion. Others suspect that the properties of the dark energy driving today's expansion are not as constant as we assumed. Others still hold out hope that some subtle, stubborn error in the measurements will eventually be found. But year after year, as both methods are sharpened, the gap has refused to close, and the hope of a simple mistake grows thinner. It is one of those rare moments in science where the numbers are good enough that they cannot both be right and cannot both be wrong, and the tension between them is pointing at something real that we have not yet named. The deeper unease is what the tension implies about our confidence in general. We tend to imagine that the foundations of physics are finished, that the great work was done a century ago and we are merely filling in details. The Hubble tension is a reminder that this is not so. Here is one of the most basic numbers you could ask about the universe, how fast it is growing, and our two best ways of measuring it disagree, out in the open, unresolved. If the ground is unsettled here, on a question this fundamental, then the confidence we feel about the rest may be more provisional than it appears. And that unsettling of the ground is the perfect place to open the next door, the one that asks not how the universe behaves, but what it is made of underneath. Now, from that real and solid crack, physics opens some doors into more speculative territory, and I am going to walk you up to those doors and show you what is behind them, but I am going to hold your hand the entire way, because these are exactly the ideas that get twisted into fear, and I refuse to leave you frightened over things that do not deserve your fear. The first door is a possible far future fate called the Big Rip. If the expansion of the universe is not just continuing but accelerating, and if that acceleration were to keep intensifying, then there is a scenario in which the expansion eventually becomes so violent that it overwhelms everything. First it would tear apart the clusters of galaxies, then individual galaxies, then solar systems, ripping planets from their stars. Then, in the final moments, it would overcome the forces that hold matter itself together, and atoms would be pulled apart and the fabric of everything would dissolve. It is a genuinely discussed possibility. But I want you to hear the important part clearly. It is a far future scenario, not a prediction, and even in the versions where it happens, it is unimaginably distant, billions of years away or more, and depends on assumptions about dark energy that we do not know to be true. It is a shape the mathematics can make. It is not a thing coming for you or anyone you will ever know. The second door behind the crack is the strangest, and it has the most fearsome name, and it deserves the most care. It is called false vacuum decay. The idea starts with a subtle point about empty space. We tend to think of a vacuum, empty space, as the absolute bottom, the lowest possible energy state, a floor you cannot fall through. But quantum physics raises an unsettling possibility. What if empty space is not sitting at the true bottom, but on a kind of ledge, a state that looks stable, that has been stable for the entire history of the universe, but that is not actually the lowest it could go? This is tied to real measurements, to the mass of the Higgs field that gives particles their mass and the mass of the heaviest known particle. And when you plug those measured numbers into the equations, they land, intriguingly, right near the boundary between a universe that is truly stable and one that is only apparently stable. And if the vacuum is only apparently stable, then in principle, at some random point, it could tunnel to the true bottom, forming a bubble of true vacuum in which the laws of physics are different. A bubble that would expand outward at the speed of light, rewriting reality as it went. I have just described something that sounds like the end of everything, so now let me do the most important thing I will do all night, and put it in its proper place. The probability of this happening on any timescale that matters to any living thing is, as far as our best physics can tell, effectively zero. Physicists discuss false vacuum decay not because they are worried about it, but because it is a profound statement about the deep, deep stability of the universe over spans of time that dwarf its entire current age many times over. It is a statement about the character of reality, not a threat hanging over your night. I bring it to you for wonder, not for fear, and if you take only one thing from this part of our journey, let it be that the ground beneath you is, for every purpose you will ever have, solid. What has genuinely changed is subtler and stranger than any doomsday. It is that physics, for the first time, is no longer entirely certain that the laws are eternal. The word almost has crept in under the foundations of reality, where it never used to belong. The stage is not collapsing. But we have learned that it is a stage, built of specific values that could conceivably have been otherwise, and that is a humbling thing to know. And it leads directly to the deepest question of all, the one that asks not how stable reality is, but what it is actually made of. Because the answer that modern physics is circling is stranger than anything we have touched yet. Part 11. What we are made of. We have to ask, finally, the most basic question there is, the one a child asks and a physicist spends a lifetime failing to answer. What is the world actually made of? You feel like you live in a solid, three-dimensional place. You can move up and down, left and right, forward and back. Objects feel solid. You feel solid. The floor holds you. And yet, when we point our instruments at the most extreme objects in the universe and study the deepest mathematics of how information and gravity and space fit together, we keep arriving at a conclusion so strange that physicists have argued about it for decades, and it is this. The solidity and even the three-dimensionality of the world you live in may be a kind of projection, a surface effect. And to see why anyone would say something so bizarre, we have to look, as James Webb is looking, into black holes. A black hole is the place where the rules break, where gravity becomes so extreme that not even light can escape, and for a long time we thought of them as the ultimate trash cans, places where things fall in and are simply gone. But when physicists worked out the real mathematics of black holes, they found something they did not expect, something that has quietly become one of the deepest clues we have about the nature of reality. When a black hole swallows matter, it swallows information, the detailed description of how all those particles were arranged. You would naturally assume that this information goes inside the black hole, filling up its volume, packed into the three-dimensional space within. But the mathematics says no. The amount of information a black hole can hold does not depend on its volume at all. It depends only on the area of its surface, the two-dimensional boundary around it, the event horizon. Double the surface, and you double the information it can hold. The inside, the volume, does not enter into it. It is as if you threw an entire library into a box and discovered that the books were not stored inside the box at all, but somehow written across its outer walls, and that the inside of the box was, in some deep sense, an illusion. This result, that the information content of a region depends on its surface and not its volume, is real physics, worked out by careful people, and it leads to one of the most vertiginous ideas in all of science, the holographic principle. If the information describing a black hole lives on its two-dimensional surface, then perhaps the same is true of everything. Perhaps the information describing our entire three-dimensional universe is, in the deepest sense, encoded on a distant two-dimensional boundary, and the rich, solid, three-dimensional world we move through is a projection of that flatter, more fundamental reality. Think of the hologram on a credit card or a banknote. It looks three-dimensional. Tilt it, and you can see the sides of the image, see depth in it, but run your finger across it, and it is perfectly flat. The depth is a trick of how light plays off a two-dimensional surface. The holographic principle suggests, at least as a serious mathematical possibility, that you are the bird on the credit card. That the real information that is you may be a pattern on a distant surface, and the version of you sitting there feeling the weight of your own body, feeling solid and deep and three-dimensional, is the projection. Now I have to be honest with you, more honest than ever, because we have crossed from measurement into interpretation, and the line between them matters more here than anywhere. The holographic principle, in its precise mathematical forms, is taken very seriously in theoretical physics. It has been a productive, powerful idea. But the leap from that mathematics to the sentence "you are a projection" is a leap into philosophy, not measurement. No experiment has shown that you are a hologram, and the next step, the one everyone reaches for, is even further out. Because once you start thinking of the universe as information encoded on a surface, projected into what looks like solid space, it is a very short step to a word that makes people uncomfortable: simulation. If reality is, at bottom, information being processed and projected, then some people ask whether the universe might be, in effect, a computation. And they point back to everything we have seen tonight: the galaxies that formed too fast, the tension in the expansion rate that will not resolve, and they say, do those not look a little like glitches? Like errors in a program, like a world being rendered on the fly, occasionally getting the math slightly wrong. I understand the pull of that idea, and it is worth sitting with as a thought experiment, but I am going to plant my feet here and tell you the truth about it. The simulation idea, as satisfying as it can feel, is something we currently have no way to test. It cannot be proven or disproven with any instrument we possess. It explains everything and predicts nothing, and an idea that can explain any observation equally well is not doing scientific work, it is doing poetic work. The anomalies we have discussed are far more likely to be genuine features of a real universe that we do not yet fully understand than they are to be bugs in a program. So hold the simulation idea gently, as the interesting speculation it is, and do not let it convince you that your life is less real, because there is nothing solid beneath that conclusion, only the vertigo of a good story. But underneath all of this speculation, the holograms and the simulations and the pixels, there is one thing that is not speculation at all, one process that is as solid as physics ever gets, and it is the thing this whole part has really been building toward. It is entropy. The second law of thermodynamics says that in any closed system, disorder increases over time. Order is fragile and rare, and it takes constant energy to maintain, and the universe is always, patiently pulling everything apart. A hot cup of coffee cools, a sandcastle crumbles, a living body ages. This is not an interpretation, and it is not a maybe. And there is a way of stating it that reaches all the way down into what you are if you are willing to follow it. Everything you are, your body, your memories, the particular pattern of connections in your brain that makes you yourself, is a structure, an arrangement, a specific and improbable order held together against the pull of disorder. To keep that order, you have to spend energy, constantly. You eat, you breathe, you sleep, and all of it is, in the deepest physical sense, work done to hold your pattern together for one more day against a universe that is always, gently, trying to smooth it back into sameness. Aging is that battle slowly being lost. Every memory you hold degrades a little each time you touch it. Every cell that divides copies itself a little imperfectly. We are, if you want to be stark about it, patterns slowly becoming unreadable, structures the universe is patiently unwriting. That is not meant to frighten you. It is meant to make the next part land, because the response to this fact is the whole reason we came all this way tonight. Because notice what your very existence is, seen against this law. In a universe whose fundamental tendency is toward disorder, toward cold and sameness, and the erasing of all structure, you are a place where order is being actively, stubbornly maintained. You are a knot of improbable arrangement that has held its shape for years, taking in energy, holding the chaos at bay, and while you do it, you are also doing the most improbable thing of all, which is noticing that any of this is happening. The universe runs downhill toward disorder everywhere, in every galaxy, in every dying star, and here, in you, it has briefly, locally, run the other way, and become something that can look at the downhill slope and understand it. That is not a small thing. That is, when you see it clearly, close to a miracle, and it is the hinge on which the whole night is about to turn. It is the most reliable law we have, and it points in one direction only, from order toward disorder, from structure toward sameness. And when James Webb looks at old dead galaxies, galaxies where the stars have finished forming and are slowly burning out with no new ones to replace them, it is watching this law play out across the sky. It is watching the universe run down. Everything we have marveled at tonight, the galaxies, the stars, the structures at the dawn of time, and yes, you, your body, your memories, your mind, is a temporary pocket of order in a universe that is sliding, slowly and irreversibly toward disorder. That is the one fact underneath all the speculation, and it is the one that presses hardest because it is coming, in its own unhurried way, for everything you are. which is exactly why the last question we have to ask is not what will destroy us, but what, if anything, we are supposed to do about it. And before we can answer that, there is one more strange door to open, the one that asks whether any of this ever really ends at all. Part 12. The Loop That Will Not Let Go. We have followed the universe down toward its ending, toward entropy and heat death, toward the slow running down of all order into cold and quiet. It sounds final. It sounds like the last word. But there is a mathematical idea, strange and beautiful and genuinely unsettling, that suggests the ending might not be the end after all, and I want to walk through it with you carefully, because it presses on something very deep, and because it is easy to get wrong in a way that turns a subtle idea into cheap horror. I do not want to do that to you. I want to give you the real thing, honestly held. The idea begins with a simple observation about anything that is finite in its parts, but endless in its time. Imagine a deck of cards. There are only so many cards, and therefore only so many possible orders you can arrange them in. The number is enormous, but it is finite. Now imagine you shuffle that deck, and shuffle it again, forever, without ever stopping. Because there are only finitely many possible arrangements, and because you are shuffling for an infinite time, something inevitable happens. Eventually you must return to an arrangement you have seen before. In fact, you must return to every arrangement over and over infinitely many times. Given endless shuffling, the exact order the cards are in right now will, someday, come back. This is not mysticism. It is a mathematical certainty about finite systems given infinite time, and in physics it has a name, the Poincare recurrence theorem. Now here is where it becomes something more than a card trick. The universe, or at least a closed region of it, can be thought of as an enormous but finite collection of particles, and those particles are constantly being rearranged, shuffled by the laws of physics. And if time truly is infinite, if the universe or some version of it simply keeps going forever, then the same logic applies. Any particular arrangement of matter that has ever existed must, given enough time, recur. And that includes very specific arrangements. It includes the exact arrangement of atoms that is the Earth. It includes the exact arrangement that is you, sitting where you are, thinking what you're thinking. The theorem says that after a span of time so long that writing the number would be meaningless, a stretch that makes the current age of the universe look like nothing, those atoms must, by pure necessity, fall back into precisely this pattern. You would happen again. Not a similar person. You. And you would not remember any of the time in between, because your memory is part of the pattern that reassembled. So from the inside, it would feel like no time had passed at all, like a single unbroken moment. I have to catch this before it runs away with you, because this is exactly the kind of idea that gets told as though it were established fact, and it is not. Poincare recurrence is real mathematics, but in physics it is used mostly as a warning sign, not a promise. When a chain of reasoning leads you to conclude that you will live again, unchanged, an infinite number of times, most physicists take that not as a prediction about your fate, but as a signal that one of the starting assumptions is wrong, most likely the assumption that the universe is truly closed, finite, and eternal in the right way. The expanding universe we actually observe probably does not satisfy the conditions for this kind of return. So please do not walk away tonight believing that science has proven you will repeat your life forever. It has not. What it has shown is that if you take certain premises and follow them all the way to infinity, you arrive at something overwhelming, and that the overwhelming result is usually the mathematics telling you the premises need fixing. It is a haunting thought held honestly. It is not a sentence. Still, it is worth sitting for a moment with why an idea like this presses so hard on us, because the pressure it creates is itself revealing. Long before any physicist wrote down a theorem about finite systems and infinite time, a philosopher named Friedrich Nietzsche posed almost the same thought as a test of character. He imagined a demon slipping into your quietest moment and whispering that you would live this life again and innumerable times more, with nothing new in it, every pain and every joy returning in the same order forever. He did not offer it as physics. He offered it as a question. Would that knowledge crush you? Or could you live in such a way that you would welcome the repetition, that you would say yes to your life so completely you would be willing to have it again without end? He called it the heaviest weight, and he meant it as a strange kind of gift, a way of asking whether you are living a life you would choose to relive. It is remarkable that the cold mathematics of recurrence and the old fire of that philosophy end up knocking on the same door in you, and notice which door it is. The reason recurrence and the demon's whisper both unsettle us is that they take the one thing we assume is ours alone, the singularity of this life, this exact once-only passage through time, and they threaten to multiply it or erase it. That reaction, that flinch, is worth paying attention to, because it tells you something you actually believe. You believe this moment is real and precious and yours. The theorems cannot take that from you, and honestly, they were never meant to. They are the mathematics reaching its own limits and reporting back that the assumptions must break somewhere. What survives the whole strange exercise is the flinch itself, the stubborn conviction that being here, once, now, matters. Hold on to that conviction. In the next few minutes, it turns out to be the most important thing you own. And there is a companion idea, stranger still, that I include for the same reason, as a genuine puzzle rather than a fright. It is called the Boltzmann brain, and it comes from thinking hard about randomness and probability in a universe left to fluctuate for eternity. The reasoning goes like this. If the universe is a place where matter randomly shuffles, then order can occasionally arise by chance. The way, if you shook a box of watch parts for long enough, one time in an unimaginable number of tries, they might fall together into a working watch. But here is the unsettling twist. A whole ordered universe, with its billions of galaxies and its consistent history, is an enormous amount of order, fantastically unlikely to arise by chance. A single conscious mind, by contrast, just a brain with a set of memories and the feeling of a moment, is a far smaller amount of order, and therefore, by the cold arithmetic of probability, vastly more likely to pop into existence from random chance than an entire coherent universe is. And this raises a genuinely disturbing question that physicists actually argue about. In a universe that fluctuates for eternity, there should be far, far more of these lone momentary minds, complete with false memories of a past that never happened, than there are real observers with real histories. So which are you? The real thing, with a genuine past, or a momentary fluctuation, hallucinating this entire night in a flicker before dissolving back into the dark? I raise it, and then I set it gently down, because like recurrence, the Boltzmann brain is used by physicists not as a claim about you, but as a tool, a reductio, a way of testing theories. If a model of the universe predicts that most observers should be these lonely flickers, physicists tend to conclude that there is something wrong with the model, not that we are all hallucinations. The strangeness is a feature of the argument, pointing back at the assumptions, not a description of your reality. So hold both of these, the eternal return and the momentary brain, the way you would hold a strange and vivid dream on waking, with interest and a little wonder, but without letting them convince you that this moment is anything less than real. Because here is what I most want you to notice about this whole descent we have made tonight, down through impossible galaxies and shrinking horizons and unseen pools and rotting foundations and projected realities and looping time. At every level, the universe has seemed to grow larger, stranger, colder, and more indifferent to you, and you might reasonably feel by now very small and very temporary and very alone. So now, finally, I want to turn the whole thing over, because there is a way to look at everything we have seen that changes not a single fact, and changes absolutely everything about what those facts mean, and that turn is the real reason I brought you all this way. Part 13. The Trap is a Spacesuit. Let us lay out the whole picture at once, everything we have gathered tonight, and look at it honestly before we turn it over. We have learned that the universe is older or stranger than the story we were told, with galaxies at the dawn of time that should not have had the time to form. We have learned that it is bounded, that we live inside a bubble whose edges are quietly slipping away, carrying whole galaxies permanently out of reach. We have learned that we are being pulled and pushed across that bubble at more than 1,000,000 miles an hour by forces we cannot see, and that something outside our horizon may be tugging at everything within it. We have learned that the sky is silent, that we may be alone, or hunted, or simply the first. We have learned that the very stage of physics may not be eternal, that reality may be a projection, that time itself might loop, and through all of it, one law has stood underneath, patient and certain, the slow running down of all order toward cold and silence. If you stop the story here, there is only one honest word for what you're left with, and it is despair. A small, temporary, accidental thing, alone in an enormous, indifferent, disintegrating universe. That is where the facts leave you, and it is exactly halfway to the truth, because here is the turn, and I have been carrying it for you all night, waiting for this moment to set it down. Ask yourself what all of this cosmic indifference actually means for you, and notice that it can be read two entirely different ways. If the universe is indifferent, if it has no plan for you, no purpose written into your atoms, no destiny you are required to fulfill, then yes, that means the cosmos will not comfort you. But it also means something you may never have let yourself feel. It means you are free. It means there is no cosmic exam you are failing, no grand assignment you are neglecting, no universal judge measuring your small life against some enormous standard and finding it wanting. The universe wants nothing from you, because the universe wants nothing at all. It is too busy being what it is to watch you, and that is not a prison sentence. That is a release. You have been handed the one thing a purposeful universe could never give you, which is the authority to decide entirely for yourself what matters. I want to give you an image for this, because it is the oldest and truest image I know for the situation we are in, and it comes not from a telescope but from a sinking ship. You know the story of the band on the deck of the Titanic. The ship has struck the iceberg. The water is rising. The mathematics of the situation is settled and cruel. There are not enough lifeboats. The vessel is going down, and the musicians know it. They know with certainty that the freezing water is coming for them within the hour. And so, standing on the tilting deck in the cold, with the end in plain sight, they do the one thing that makes no practical sense at all. They lift their instruments, and they play. The music does not patch the hull. It does not slow the water, or summon a rescue, or save a single life. By every measure of survival, it is a waste of the last energy they have, and it is, I think, the most human thing anyone has ever done. Because in the face of certain entropy, in the face of a cold and indifferent physics that was always going to win, they chose to make something warm and ordered and beautiful anyway, for no reason except that they could, and that it was theirs to make. That is us. That is all of us, on this small, warm world, playing our music on the deck of a universe that is slowly going down. The iceberg is entropy, and it is real, and it is coming, and there is no lifeboat from the second law of thermodynamics. But every time you love someone knowing you will lose them, every time you make something beautiful that will not last, every time you laugh, or help a stranger, or look up at the sky and feel wonder instead of fear, you are the band on the deck. You are choosing to make order and warmth and meaning in a universe that offers none for free. And that choice, precisely because it is not required, precisely because the universe does not care, is the most defiant and dignified thing it is possible to do. Physicists have a name for things like us. They call us dissipative structures, patterns that hold their shape by taking in energy and holding disorder at bay for a little while. We are pockets of order in a rising tide of chaos, and yes, eventually the tide wins. Eventually the music stops and the instrument sinks. But for as long as the song lasts, the chaos is held back, and something exists that did not have to, and that is not nothing. That is in fact the only victory anyone or anything in this universe ever gets, and it is enough. Now let me answer, at last, the question the whole night has been circling, the one we started with when we pointed that $10 billion eye at the beginning of time. What is the true scale of the universe? I told you at the start that most people hear that question and think of size, of light years and galaxies and enormous numbers, and I promised you that James Webb had revealed a different kind of scale. This is what I meant. The true scale of the universe is not its size. It is the size of the mystery. It is how much larger the unknown turned out to be than the known, how every answer widened the questions, how the more we saw, the more we understood how much there is that we cannot yet grasp. And here is the thing about that kind of scale. The reason it is not, in the end, a reason for despair. A universe that is merely large would diminish you, but a universe that is genuinely mysterious, genuinely open, still being discovered, is a universe that needs something in it capable of wondering, and that is you. That is the rarest thing in everything we have surveyed tonight. Consider what you actually are, measured honestly against everything else in the cosmos. A galaxy is enormous and beautiful, and it does not know that it exists. A black hole is powerful beyond imagining, and it feels nothing. A star can burn for billions of years and never once ask why. In all the immensity we have crossed tonight, all the impossible galaxies and shrinking horizons and unseen currents and looping time, the universe was silent and unaware of itself, a machine running in the dark. And then, on at least one small world, and perhaps only on this one, matter arranged itself into something that could look back. Something that could point an instrument at the dawn of time and be moved by what it saw. Something that could feel the loneliness of the silence and choose, in spite of it, to keep the candle lit. A single conscious thought, the kind you are having right now, is more complex and more improbable and more precious than 1 billion burning stars, because the stars, for all their fire, cannot do the one thing you're doing this very moment. They cannot know. You're not small against the universe. You're the part of the universe that woke up. You're concentrated where everything else is scattered. You're the noise in the silence, the warmth in the cold, the rebellion against the running down of all things. You are the glitch that refuses to be fixed. So do not let the size of the sky make you feel like nothing. That was always the wrong lesson. The right lesson is the harder and better one. This moment, this exact configuration of atoms and awareness and quiet attention, the specific slice of the universe that is you, listening to this right now, will never happen again in the entire history of time. In all that infinite shuffling, this exact combination of light and warmth and thought is a limited edition of one, and it is gone the moment you move on. The trap of time is real. The physics is indifferent. The entropy is rising, and the horizon is shrinking, and the ground is not quite as solid as we thought. We cannot escape any of it, but we can decorate the walls of the room we are in. We can fill the silence with our own music. We can turn the whole enormous, strange, frightening machinery into a place where, for a little while, someone was awake and paying attention and glad to be here. And that, in the end, is what the telescope really revealed. We built it to measure the scale of the universe, and it did, but the number it returned was not the one we expected. It measured, without meaning to, the scale of the thing looking through it. It showed us a cosmos almost beyond comprehension in its size and age and strangeness, and then it showed us that the only place in all of that immensity where any of it was ever seen, or understood, or cared about, was here, behind the eyepiece, in us. So the next time you step outside on a clear night and look up, and feel that old, familiar smallness, I want you to remember what we found tonight. That the darkness up there is not empty, and it is not a threat, and it is not looking down on you. It is waiting to be seen, and you are the seeing. Keep the light lit, stay awake to it, and do not, whatever you do, mistake the size of the sky for the size of your life, because a galaxy cannot love, and a black hole cannot wonder, and the whole enormous universe, for all its scale, cannot do the small and impossible thing that you're doing right now, which is simply this: to be here and to know it. Thank you for staying with me tonight. Sleep well, and do not forget to look up.